I think I could be a pretty good pirate at the sea. Okay, so another lens problem, but this time instead of converging lenses, we're going to diverge. So what we're going to do here, we're looking at a double concave lens here, so it's a diverging lens. And our question asks, where must a small insect be placed? Ooh, disgusting. In a 25 centimeter focal length diverging lens to form a virtual image 20 centimeters in front of, weird space, of the lens. We're just asked to draw a ray diagram to depict this, and you know what, we might as well, while we're at it, just like kind of work out the math and figure it out. But let's do the ray diagram first. So we know that our focal length of this diverging lens is 25 centimeters. Okay, and if I kind of scale my fingers once again to try to get this right, because I don't have a ruler with me and I'm working on a computer monitor, that looks about even. I want this image, this virtual image, to be like right here. Okay? Well, where do I need to put the object then? Well, because this is a diverging lens, I'm always going to have my image appear virtually on the left side of the lens because that's going to be where my object is located. Okay, so maybe I drew that a little bit too big. Let's draw this one a little bit smaller for our image. So let's make our image a little smaller. And let's just throw our object back here somewhere. Okay, why did I make it big again? It's going to be this high. When we draw our ray diagrams to depict this, what's going to happen is the light's going to come in a straight line. And technically, whenever it hits this lens right here, it bends twice at the first, coming into the lens itself and then leaving the lens. But if we just think about it as an ideal lens, it's going to bend away. Okay? This is the direction the light's going. We can also draw a line that goes directly through the center of the lens. Now, if I look at these two lines on the right side, they're not even close. They're completely diverging. So that's anti-bueno. That's no good. How am I going to see anything? So this is going to create a virtual image because we have to backtrack these lines. And actually, the only line we have to backtrack here is the one that went up, the one boxed in pink. When we backtrack this line, I'm going to try to keep this as parallel as possible. We backtrack it so that it passes through the focal point. And in doing so, we see that I just missed the image spot, and that our image should actually appear right here. Okay? That is where our image will be from this ray diagram. So the line diverges up here, and because of that, we have to backtrack it. It passes through the focal point as light should. And that's just the ray diagram. If we wanted to actually work out the math here and kind of like prove what would be happening, it is very important to remember that for a diverging lens, our focal length will be negative. So our focal length is a negative number, okay? Not only this, but the light is physically on the right-hand side. Because we see the image over here on the left, this also means that our image distance is going to be a negative number as well. So these are two important things to recognize for a diverging lens in order for us to solve this problem. Because once we recognize that, we can just set up our simple lens mirror equation and solve this out. We know that 1 over f equals 1 over di plus 1 over do. And we know our focal length is 25 centimeters, and the image will form 20 centimeters in front of the lens. So we're going to have 1 over 25, and it's negative, equals negative 1 over 25 plus 1 over do. If we want to go ahead and solve this for do, we can add 1 over 25 to each side. My computer went insane. adding 1 over 25 to each side. So we have negative 1 over 20 plus 1 over 25. And, or did I have that backwards? Oh, I had that backwards, don't I? No, do I have that backwards? What was it? The image is 20, the focal length is 25. Oh, I had that backwards. I knew it. I knew something was weird. Tisk tisk. The reason I knew something was weird there, and I was like pausing for a second, was because when I add the 1 over, when I was trying to add the 1 over 25 over, I'm looking at this and I'm saying, wait a second, that would give me a negative number. And I know that's not possible because I know DO needs to be positive. So what's actually going on here is we're going to get negative 1 over 25 plus 1 over 20. That's a positive number. That works out. That's what I like. And now when we throw this in a calculator, 1 over 25 gives me negative 0.04 plus 1 over 20, which will be 0.05. This will equal 1 over DO. So we see 0.01 equals 1 over DO. And then when we reciprocate both sides, we flip that, we're going to pretty quickly find that our value of DO is going to be 100 centimeters. Okay? And that will make sense because that's a positive value, which implies that our object starts on the correct side of the mirror. And that does work there too, because if we take a look at our mirror here, our object starts on the correct side of the mirror, the light then moves across, and we've backtracked so that the image is negative. Okay. Naturally, if you wanted to do what our magnification is, if you actually wanted to work that out, you know the magnification is negative di over do. So in this case, it would be negative of my negative, so positive. Di in this case was 20, and do is 100. Wait, did I have that backwards? I have that backwards. Oh no, I had that right. Yeah, that's right. Oh, geez, why am I stuttering so much? So that's going to be 0.2. And this implies that the positive says it's going to stay upright, and the 0.2 means that this is going to be much, much smaller in this problem. So our object is back here, it's large. Our image is up front, it is small. That is what we see with our magnification. So just another pretty straightforward lens problem. The only key here is we have diverging lenses. We need to recognize that our focal length will be negative and our image distance will be negative as well. So with that, this problem is finished. We've got one more to do. That's going to be a double up. But for right now, adios and take it easy.